Hello, everyone. I'm Spectre. With me is Z, and welcome to the binary episode of the Day Zero podcast for this week. This kind of passed me by yesterday, and Z brought it up after the bounty episode, but this is actually our 100th week doing the podcast, so that's a pretty awesome milestone. So I thought I'd give it a quick highlight here. But
Yeah, I
yeah,
mean, we're well beyond 100 episodes now since we switched over to the to weekly, but 100 weeks is a nice milestone.
I kind of consider each episode to be like a half episode. So
Yeah,
yeah,
my naming convention, like on my note files, I do like this week is episode 22 of our second season in theory, so I kind of group them together too.
yeah, seasonal model is fun too. But yeah, as always, Z will cover the spot the Vuln solution for this week, which somebody actually got in chat just a few minutes ago, and then we'll get into topics.
Yeah, this week's Spot the Vuln, actually, right in chat here, Big Rick 7815 basically got it head on. The problem here is, well, for one, I guess, those of you watching, you can't quite see all of the code. See if I can zoom out a bit. There we go. Issue here kind of comes down to a difference, or at least when I first saw this code, I kind of copied this challenge somewhat from elsewhere, inspired by it. What stood out to me was the fact that it did the HMAC um over the basically 34 plus size. So length of whatever the hash is plus size. So all of the extra data, it did the payload over that and it took into account that size, but when it returned all of the data. It's just seeing that data 34 and whatever's after it. So the fact that it doesn't verify all of the data it's returning is likely to allow you to introduce another issue later on. I didn't bother including some actual code that would be exploitable in this way. Because the core issue here is the fact that it just doesn't actually validate all of the data it returns, or alternatively, it doesn't validate that the length of the whole packet is the expected length. That it does this check here on line 14 to make sure it has enough data, but it could also be checking to make sure it doesn't have too much data. So there's kind of two ways you can look at that.
Yeah, so you can
But
kind of
yeah,
tack on unsigned data at the end, basically.
yeah, and that is it's a reasonably common issue you see when people try and roll this out on their own. You'll see this sort of mismatch sometimes when they just, aren't really thinking about basically all of the security considerations that need to be thought about when you're rolling your own crypto system. Like, just because they're using an existing hash, I'd still call this, rolling your own crypto.
Which is why rolling your own crypto system is a bad idea.
Yeah.
But yeah, I mean, this was kind of a cool challenge. You asked me, I didn't really get a chance to look at this challenge too much before we started, but I wasn't able to spot it in like the 1 or 2 minutes we had before we started the show. But yeah, I mean, it's kind of subtle. You kind of have to be thinking of that case to spot it, and look at how the validation is happening more closely with regard to the length. But yeah, cool challenge. All right, so we'll get into our first topic here, which is a bug in a cool area that we don't really see too often, being a bug in the boot ROM of the Zynq-7000, which, for those not familiar, it's a Xilinx SoC, which is a hybrid of an ARM processor and an FPGA. It's actually really cool. I wasn't even really aware that this type of product existed, though it totally makes sense. Basically, what it's for is it allows you to like build your own device or chip with the FPGA, and then you can use the ARM core to interface with it from the software side. So very useful product for like hardware dev, um, and just a very cool one to look at from a security perspective. One of the many features that it has
Although,
is,
isn't this something like a decade old? I think they call that out at some point here.
yeah, I think this chip is a bit old. So yeah, I guess this kind of product was new to me. I wasn't really like I've dabbled a little bit in FPGA stuff. I bought an FPGA that's collecting dust on my desk. Like I haven't used it since I bought it. But I am very interested in that area. Um and yeah, I just wasn't really aware that that type of product existed, but yeah, it's been around for a while, like you said. But one of the many features that it supports is secure boot. So it tries to protect the integrity of the boot chain and sign various things, such as the register initialization list, which is a list of addresses and data tuples used to initialize hardware. You know, just writing to like memory registers for initializing whatever peripherals you might have connected to it or whatever. Um, Now, interestingly, because of how the boot process works, you can actually smash that register initialization list with your own data, and some code in the boot process will operate using that data before any of the signature checks are actually performed. So, if you can get code execution in that window, it kind of opens up some attack surface based on that register initialization list. Now, there is some whitelisting being done on the addresses in that list, which is even further restricted when secure boot is enabled in the header. Though the header kind of has the same problem where you can disable the secure boot flag, and that will like invalidate the signature, but it's still going to run some code before that signature is checked. Um, so what they did here is pretty cool. They basically emulated the ROM using Unicorn's Python bindings and did some hooking and whatnot to try to like fuzz or iterate the addresses or registers in the initialization list to try to find some problems. They ended up finding two registers that are used for secure digital input output or SDIO. The SDIO controller has like an SDMA subsystem, which is Smart Direct Memory Access, I believe. And what's important there is you can issue DMA commands using the transfer mode and transfer size registers in the SDIO controller's memory region. And when you issue those DMA commands, there's an internal DMA buffer that has some internal tracking. So when you send a command, and let's say you use like one block or 512 bytes, which is the block size here, um, it'll increment that pointer in the buffer for the next command. So yeah, the DMA is based on blocks of 512 byte size. The buffer going off of the comments in the code is or the comments in the disassembly is 4 kilobytes in size. So you can kind of guess where this is going. There's a potential buffer overflow there where you can send multiple blocks past the end of the SDMA page buffer, and it just so happens that after that page buffer, along with some other stuff like the fat file system tables, there's a boot function pointer sitting there just kind of waiting to be corrupted. So by writing into those registers with the register initialization list to issue a multi-block SDIO command, you can overflow and corrupt the boot function and gain code execution before the signature checks are run. Since you have code exec, you can just walk around those signature checks. They don't really matter anymore because you have control. So yeah, kind of an interesting attack surface to look at here. The exploitation was a little bit tricky, or more tricky than you might expect with like the bug's nature. For example, there was some checksum stuff going on between the corruption point and the boot function pointer that had to be passed. I think that relied on some header information that they had to account for in their exploit image. They also had to fake the fat file system tables and fix them up. There was also some timing issues where they had to allow for enough time for the SDIO transactions to complete. So they had to do some dummy writes, and they also messed with the clock speeds, I think. So they like uh, sped up the clock speed at first and then slowed it down after they sent the malicious payload, I think. And they use a logic analyzer to try to tweak those timings. They don't go into too much detail there, but yeah. Now this attack does require a pretty significant amount of access from an attacker. They would need most likely physical access to the device and the ability to either swap or modify the SD card, which is quite a high ask. And
It
Xilinx doesn't
is,
consider
but
physical attacks as part of the threat model here, but there are some scenarios where this could be taken advantage of.
like it is a high ask, but at the same time, secure boot, like that's also kind of the point. Is in part like not being able to compromise the device at that level. And most attacks at going after like the boot image aren't going to be attacks at like, memory corruption in the software being able to compromise it. Most attacks are at that hardware level. So I think it's completely fair to kind of ask for that at this point. Yeah, it is just like the ability to change that boot bin, I guess, sorry. Um I think it's pretty fair to kind of include that as an attack.
For sure, and Xilinx agreed because they put out an advisory about it. I think in their advisory they cited that in some cases it might be possible to hit this remotely if there's some setup where the SD card can be rewritten remotely or whatever. I found that a little bit weird, but they mentioned it in the advisory and they acknowledged it, so that was cool. Um, Baliga mentioned in chat a bit earlier before we got into this topic, asking if it was like a design flaw issue or if it was like by design or if it was a bug. Here it's kind of interesting because there's multiple issues that allow this attack to take place. The like point of the post is about the buffer overflow that allows you to get code execution, but you wouldn't even be able to exploit that if you weren't able to overwrite those register initialization lists, which are signed, but the signature check is so late. That on its own is kind of could be considered its own issue. Uh, Although I don't know, that seems maybe a little bit hard to deal with from a developer perspective because when you're in the boot ROM, like you're gonna need like I doubt you can run the signature checks right away. You're gonna have to pull some information before you can do that to initialize the device, I would think.
Yeah,
So this seems like kind of a hard problem.
there's always you want to reduce that attack surface as much as you can. But it is a hard problem. At least as far as I'm aware, this isn't an area that I've like done active development in. But as far as I'm aware, like it is a hard thing to secure against any possible attack. Like you've always got at least that little window beforehand. Like if I recall, even the Switch, the big compromise on the Nintendo Switch was one of these sort of pre-secure boot things. Like there's always something going on before you actually are able to get to the full boot, where it does all of that validation. Like I I am actually not even sure what I would necessarily suggest here. Besides just trying to get the signature check earlier, further whitelisting. Like if you could just have all of this hard coded, completely unchangeable, that's great. But because it's also like on an SD card, probably not an option. So you're kind of left with like you need to get some initialization code up. You need to, be able to access and communicate with the SD card. It's a hard thing to solve. Like usually I'm able to say like, yeah, just do whatever. I don't really have that answer here. I'm sure there is. Like if somebody was working on this more often, I'm sure they know exactly what the like industry standard is for preventing that. It's not an area I'm too experienced with to make that recommendation. Um
I don't know if maybe you could use the trust zone on the ARM core in some way to do like attestation. I don't know.
Do they even
I
have
don't
this
know
on
enough.
this ship though, or have that?
Well, they do have an ARM core. I I'm not sure what like version of ARM it's running. I would imagine like it would have trust zone, but where it's an older chip, maybe not. That's just kind of something I was thinking of while you were talking there. I don't know if that would really be viable with this setup. I'm kind of, you know, speculating in the wind here. Like you, I'm not really that familiar with like FPGAs and what's needed in the design here, but that's just kind of something I thought of where they're using an ARM core. They might be able to take advantage of that.
Yeah, like
Although
oh,
Belika says technically the boot ROM runs as trust zone. Okay, fair enough. Yeah, when you get to that like low of a level, it's like really hard to secure against an attacker with this kind of level of access. I remember like quite a while ago now because SGX is completely dead. But we were talking about some white papers that had attacks on Intel SGX. For those not familiar, that's like their secure enclave technology, or it used to be. They had kind of a similar problem where they had page tables that were protected later on in the boot process, but at the beginning, you could kind of DMA over them or whatever as an attacker, and there was nothing they could do about it. So it kind of significantly nerfed or just bypassed SGX at the gate. So yeah, it's a problem that's been seen before in other products too.
yeah, I mean it, and like I said, it seems like a hard problem.
Okay, so Beliga says, yeah. So technically, the boot ROM runs as trust zone, then it loads trust zone and drops privileges. Okay, that makes sense because yeah, the boot ROM is pretty much at the top of like your chain of trust, I guess. So if you're compromised at that level, then you're kind of screwed regardless. So yeah, fair enough. Um, yeah, like I said, I don't really know like how you could mitigate this attack surface a bit better. It is kind of an interesting question, and if anyone has any ideas and can throw them in comments or maybe in our Discord or something, I'd be interested in it. Because yeah, I mean this it seems kind of hard to fault Xilinx here for having this attack surface exposed. Um, Now, this is a really cool attack. Unfortunately, if you're interested in this bug, I can't really recommend the blog post too heavily, at least not at first. The advisory from Xilinx does a much better job at covering what the actual vulnerability is. It even has some diagrams. I thought this was really cool, actually. The Xilinx advisory, which I'll bring up here, had a diagram showing like whether or not you would be impacted by this issue. So they had kind of that decision flow graph where it's like, are you using a Zynq-7000 SoC device? No, it does not apply to you. Yes, and then they keep going down until it applies to you or whatever. I just thought that was kind of a cool graph, but yeah, the advisory does a pretty good job of detailing what the vulnerability is. The blog post kind of beats around the bush a little bit, and if you don't have the background knowledge of the bug a little bit from the advisory, you're probably not going to be able to see it right away. So, yeah, it's not super beginner friendly, or like friendly to readers who aren't intimately familiar with like Xilinx SoCs and boot ROM research.
Yeah, in
So you might have to
fairness,
do some external research to really understand the report too well.
yeah, in fairness, this is part 4. So there are, 4 other posts on the blog. That said, when talking about this specific bug, I don't think those other posts helped all that much. I glanced at them. I did mostly just look at this one and some of the details that I found out from other sources about this bug. Um, don't seem to be mentioned just anywhere at all. So, like, I appreciate it being called out here, but yeah.
In regards to like mitigating the attack surface and shipping fixes, Belika mentioned you can supply patches that you burn into the fuses before you sell the chip. Yeah, so uh, maybe I'll explain a little bit for those who aren't too familiar with like hardware. So it is possible for, and a lot of vendors do ship chips with electronic fuses, like tiny e fuses on the die, which they can. There's like a burn and sense circuit which they can use to blow fuses at the factory, and that basically gives them a form of like read only or write once read only memory, I guess. So at the factory, they can burn some fuses to insert some code or insert a patch or whatever, and then those fuses they can't be unblown. Um, Unless you're using maybe a multi-million-dollar laboratory with lasers or something. I don't know, but they can't feasibly be blown. But the problem with fuses is you're pretty limited on them, and they're going to consume die space. So uh, yeah, typically, like I think the Switch, for example, had like 1,000 fuses or around that number. But you like a fuse would basically represent 1 bit, because a fuse can only be either blown or not blown, which represents like a one or a zero. So you are very limited on the amount of data that you can store in fuses. So that's kind of the problem with that. Though it is like a viable vector for some things, and they're definitely used. But yeah, I mean, overall, I found it cool to learn about this type of product with like the ARM and FPGA integration. That seems like a pretty useful thing. And whenever we start talking about stuff that is at the ROM level and like the boot ROM, um, it's always a treat to see those topics because they're kind of few and far between. It's an area of research that's very niche, and uh, it's just most people don't really just don't really work at that low of a level. So uh, it's nice to cover those topics when they come up. When they come up.
Yeah, definitely caught my eye because of that. And I appreciate, like, as a bug, it's a fun little bug too. Like the early access to the data, changing some of that to get in there. It's a good bug also.
Yeah. And staying on kind of the lower level, our next research topic comes out of Principles of Programming Languages Symposium of 2021. And it's a talk about automated testing of compiler introduced security bugs across architectures, which is kind of a fascinating topic that we've touched on a little bit before, with things like different architectures providing different memory coherency guarantees and stuff. I don't remember when it was exactly, but a little while ago we shouted out a challenge that CTS posted. I think it was CTS, that was like a lockless ring buffer implementation that, if I remember correctly, was safe on x86, but it was vulnerable on ARM because ARM provided different memory safety guarantees. I think they were looser. So these kinds of architecture specific bugs are very interesting because they're pretty much under the hood and near impossible to spot from a source perspective unless you know what the compiler is going to do with that source code and you're aware of all of the nuances of the architecture. So yeah, they can be very nasty bugs that can come to bite you. So it's not too surprising that there's some research here in trying to do automated testing of that.
Yeah,
Um,
and one thing to note is, I mean, the gist of all they're doing here is comparing, uh, basically building the same software across several architectures, comparing the, what they define as like their security, all of the security comparisons, basically. Looking at those comparisons and seeing if any of them get like compiled out, or basically just there's some difference between the architectures, which might indicate that something got removed, modified, or somehow changed in a way that could introduce a vulnerability. And I think it's interesting, even if you're working on software that isn't necessarily going to be used on multiple platforms, it can still be used to discover vulnerabilities that might be introduced just by the compiler against one particular, like against the architecture that it does use. Even if the software itself isn't meant to be used across more, it's just a way of detecting where it's the compiler introducing it. It is only going to find them when the optimization that's introducing the bug comes from one of the compiler specific tasks or optimizations. That does seem to kind of be a limitation here.
Yeah, so I did want to get a little bit into the process they describe for how they do like the differential testing, and also like some examples of the types of bugs they're looking for. So on the third slide, they detail some examples. Um, the first of which was like an ARM one, or the first one that I really looked into. They have some code where like a pointer is assigned a value of hex FFFF000, so hex 1000 away from the max of a 32-bit unsigned int. And then they wrote a loop that would set each byte in that pointer to 0 for hex 400 bytes, with the ARM backend in the GCC. The ARM backend in GCC would actually emit that loop exit condition, so it would just be like an infinite loop. And I believe that's because the loop would end up iterating past the max value of the pointer, which would wrap around to null. And this one was kind of an interesting case because there was some disagreement on if this even was a bug. Because basically, what happens is the loop would iterate, the pointer would wrap around to null, and in C, a pointer can't become null by adding a value to it in the specification, apparently. So the ARM-GCC backend took some liberties there and optimized around that case. Um, that was just one example. There was another one in PPC when GCC before version 10 would optimize multiple calls of built-in darn for getting a random number into one call. So that would reduce the entropy of randomness, which has some significant security implications. So you can kind of see the pattern there. It's optimization type stuff, that certain architectures might do optimizations that other ones won't, or they'll do an optimization in a different way, and that ends up creating problems um, at the assembly level that can have security implications, and that's where their main focus lies. So what they did here was they used the Linux kernel as a test case, and they do cross-architecture testing by defining security-related operations as what they call back-end independent semantic fragments, or BISFs. Um, and basically, they find those in the LLVM IR, so they compile the kernel with Clang. They get the immediate representation. For those not familiar with LLVM, basically the C code gets compiled to LLVM IR, which is like an LLVM proprietary language, which then gets translated into machine code with like architecture specific plugins. But the important thing there is, for the most part, all architectures will share the same IR. Um, there is a bit of an asterisk there because of inline assembly, which is kind of common in the Linux kernel, but most things are going to be the same IR. So that kind of gives them a like bridge across architectures that they can use to find these patterns or find security checks. And then once they have those security checks, they search for them in the binary code in the actual assembly for each architecture, and that's where they do the differential testing. They did have some challenges there. Um, they had to identify the security checks in the first place, which in the Linux kernel, where it's so monolithic, is not really a small task. They also had to do some heuristics to try to find the security checks in the IR. There, they were like looking at the failure handling code to determine if it's a security check or not. Now, I don't really know if the researchers looked into this, but something I'd be interested in is they're doing these heuristics at the IR level. I wonder how CodeQL integration could work here. Trying to use CodeQL to find security checks and create these BISFs that they could then import into their IR analysis. I don't know. I think that could be interesting,
I mean,
and
it
perhaps
could.
easier.
I,
But
I feel like the LLVM analysis would actually be easier because then you're really just looking for like LLVM IR. The opcodes are pretty easy to kind of process over and iterate over. So if you're just looking for these comparisons that feed into like an array bounds or something, it is something CodeQL could probably do. Although the challenge there, if you're just using CodeQL is going to map things to lines of code. Whereas LLVMs, being in the IR, they can kind of look at the IR and see how that was translated into the assembly. When they're comparing the assembly outputs to look for these issues. And I feel like trying to map back from assembly to what CodeQL spits out, you're going to have some extra challenges there. So CodeQL might, in theory, be able to find different um locations for this, but you're going to be left with more of a challenge to actually map it to the same code, whereas the IR and assembly kind of go back and forth quite a bit easier.
that's a fair point. The main reason I was thinking of CodeQL potentially being useful here is just because of the powerful libraries that it has. I mean, I think there's even a Linux kernel specific CodeQL library that could be useful for something like this. But yeah, you have a trade off there where it might be easier to find them, but then it's harder to map them. So yeah, maybe they did consider it and just didn't. Uh, just decided to go with the IR parsing. Um, you say the IR parsing is easy. It kind of is. It's also
Well,
like a real pain.
there
I
are a
hate
lot of
parsing
pain
LVM IR,
points.
but
Yes,
yeah.
there are. Um, it's, but at the same time, like comparing that to all the work CodeQL needs to do, like processing just the IR is technically easier. But yes, there are some challenges to LLVM and working with their library.
But yeah, ultimately this research boils down to doing the differential testing with the arcs and the automation of the creation of points of comparison. So there's some interesting information in these slides, and their diagrams do a decent job of showing kind of their process and the workflow of what's going on there. I didn't really check out the talk. I don't know if you did, Z. I mostly
I
just
did give it a
referenced the
listen,
slides
yeah.
here. Okay.
It's what you'd expect. Since this is we don't have the paper yet, only the slides and their actual talk at the conference. Um, I was actually a little bit surprised that I couldn't find a paper anywhere.
Yeah, I
But
thought
it's
that
basically
too.
what
I
you'd
was expecting to be
expect.
able to find one.
Yeah, I mean,
Um,
in this case though, like they talk through the slides. There wasn't anything there that you're really not getting by going through the slides, besides maybe slightly better explanations or more complete. Although the audio quality was pretty bad. Like it was
uh,
listenable and everything, but it wasn't great audio. But that's a minor issue. On a whole, like I kind of like this. Just the idea, the application of it. We've talked a few times in basically the last year or so about this, like differential. Usually we see this more in the context of fuzzing, where you're looking for the differences and using that as a fuzzing comparison point or like a scoring aspect for generations and all of that. In this case, they're applying it a little bit differently, but just having that differential, it's interesting to apply here. Like it totally makes sense. They do call out some prior research, and I don't think any of the prior research was really doing this either. I mean, you do have the overhead of finding out those security checks, which is a significant overhead, but Like just applying the differential here completely makes sense. But I don't think it's ever really crossed my mind either. Granted, I've not really worried a ton until more recent times about these compiler introduced bugs. It was that an old NCC group research thing that had me thinking about it.
Yeah, along that line, I do wonder like how many types of these bugs could exist in the kernel. Um, because on the one hand, like I feel like there might be a lot of them just because they're so subtle and they just might not have been stumbled across in a specific case where they might be dangerous. Um, but yeah, I mean, it'd be interesting to see if any data comes out of like this kind of research and we start to see bugs crop up that are architecture specific. I think I've seen maybe one or two in the last year that were like architecture specific bugs in the Linux kernel, though I can't really recall details from them. But yeah,
I
I
mean,
mean,
I'm sure
it's
there's
definitely like
more.
worth the research. Even if there's not a ton of them, the ones that are there are going to be like really damn annoying to track down and root cause. So
Yeah,
yeah,
like it is such a subtle area because you can read the code and things look fine. It's only when you also have the compiler in there that you start seeing them. So, I mean, it's subtle, it's hard to find, and there hasn't been a ton of research looking at it yet.
and pulling something out of chat, Kern Exploit mentioned it's always funny how compilers assume programmers don't write UB code. And then extending on to that, Belika said sometimes I get surprised when I know how something works and turns out it's technically undefined behavior. Yeah, that does seem to be like a pain point with C that there's some common code that's out there and even stuff in like Stack Overflow snippets that are like highly upvoted and stuff that work in like most or maybe even all cases, but are technically not defined behavior by like the C standard. Um, and it's really hard to know like what is and what isn't defined behavior because programmers aren't going and reading the C specification. Like that's just unreasonable. So yeah, I mean, compilers trying to optimize around the like defined and undefined behavior kind of makes sense from their perspective because uh, optimization has been kind of cutthroat, especially now where like the hardware isn't advancing at the same rate it used to. There's kind of my favorite article, like the free lunch is over. So optimizing on the software side has become like a huge thing. So they want to optimize wherever they can, but that does end up being a problem when the developers who are actually writing C code that's getting compiled aren't aware of all of the um, potential like undefined behavior cases that the optimizer is expecting. So yeah, it's kind of an interesting problem where there's a bit of a conflict, I guess, between compiler developers and developers using the compiler.
Yeah, I mean, the compiler developers just want to have faster, better performance. Makes sense from their perspective, and it definitely kind of at times it seems like more and more often we're this is kind of being based on that NCC group presentation, talk, research, whatever that I saw a while back. Seems like they're kind of pushing to even change more of like the memory model of C itself, so it's not necessarily just an exposed like whatever the chip would do when you just incremented the value and it overflowed or whatever is what happens. They can make assumptions about it and start changing things. Um, I don't know. I mean, if the compilers keep pushing in that direction, I think we're definitely going to see more bugs of this sort.
Yeah,
Or more
because
bugs that
like
are introduced by the compiler, at least.
yeah, because all the simple optimizations that are straightforward and wouldn't cause any problems have already been done. So the optimizations have to keep getting more and more aggressive and more clever, which kind of opens up the door to more of these types of issues being present. And we're kind of seeing that in browser stuff too. Um, the meta in browser has kind of shifted to finding like these optimization type bugs in like the JIT optimizer or whatever, because they try to do these pretty aggressive optimizations that offer great performance, but there's so many like implications that have to be considered when you do them. So yeah, that's a good point. I like this will be more and more impactful or more and more common, I think, as optimizations increase and become more clever. So yeah. So we got a question that we thought would be worth discussing on the show. That's not like a typical topic that we cover, but we thought it might be worth discussing anyhow. And that was how do I learn to fuzz? And we wanted to talk about it because we talk about fuzzing on the show a lot, whether it's in passing on a topic or have a topic that focuses on it specifically, like a research paper or something. But it's a little bit hard to break into fuzzing, even though when you break it down, it's basically just throwing data at something and seeing what happens.
Yeah, I
Um,
mean, I sorry to interrupt you, but part of the reason why this question kind of took me is also just like it's a bit of like we talk about fuzzing as this blob of fuzzing, and you fuzz it and you do this fuzzing and all of that, and there's so much depth and breadth to it. Like there are all these different areas that you can go into that is a little bit overwhelming to figure out like where do you go and what actually matters. And part of the challenge there is it doesn't actually matter where you go. You're going to end up learning plenty no matter which area you kind of focus into. There's just so much flexibility in there, so many options, and we just tend to talk about it as this, like I said, as this big blob of concepts, I guess, that you can learn or do or should know about, but then there isn't a lot that really lays it out in terms of how do you start approaching this.
Yeah, and like one of the big problems I found with fuzzing personally when I was trying to ramp into it, because for a while I was kind of dismissive of fuzzing. I wasn't really like too interested in it. Though, the last couple of years has kind of changed that view. But when I was trying to learn more about it, the there's so much like terminology. Fuzzing, the fuzzing community almost has its own dictionary. So you hear these things like corpus and coverage guidance and all these things and like seeds, and you're like, I have no idea what these mean. Um, so that seems to be like one of the bigger problems with fuzzing is these terms are thrown around, and in a lot of cases they're not really explained. It's just kind of expected that you already are familiar with the terms. Um, and that kind of makes it a little bit trickier too. Unfortunately, I don't really have a solid resource I could recommend that goes through all of the terms. Maybe that's something that like maybe we could look into putting together or something. Now that I think about it, because yeah, I just don't really know of a centralized resource that talks about that. There is like the fuzzing book, which we mentioned before, which covers some of them. But yeah,
Yeah,
I
and
mean, I guess that would be the one I could recommend.
I was just going to get to the link on the fuzzing books. There's two aspects to that. The fuzzing book, I like recommending this as a resource, and I hate recommending it as a resource. It occupies this really weird space for me. So first of all, why I kind of dislike it, it's all in Python. It just feels really weird to be doing like, let's jump into a random topic here, fuzzing with grammars. And then you've got all this Python code going through, like implementing this stuff in Python. But at the same time, what I love about this is it covers a lot of the concepts that you're going to need to be exposed to. And it covers like here's what this grammar based fuzzing is all about. Here's concolic or symbolic fuzzing. Um, it goes through these topics. It also goes through different mutation things. Talks about code coverage. And using that to decide how to do some mutation, whatever. It covers a ton of those concepts, so I do like recommending it for that purpose. There's videos and lectures along. There's a ton of information here. So I do like this. At the same time, one of the other approaches, like this is useful if you want to go and actually start writing your own fuzzer. This is a lot of that information, but there's a lot of things here that you can also get quite far just like tossing AFL at something and seeing what turns up. AFL and AFL just having a few more features added on such. Um, Kind of one of my thoughts in terms of learning fuzzing is start off actually just by learning to run like AFL, maybe live fuzzer. AFL kind of being the more important one in my opinion. Just learn to run it because in running that, or AFL specifically, but in and I guess with that, AFL's documentation is better than AFL but there are so many different modes here for like modes of operation. There's so many different topics that you're going to be exposed to in just learning to use the tool. All of these different things that it's kind of just a way of forcing yourself to learn because you're using the tool, and in learning the tool, you're learning a lot of these terminology and concepts. Maybe you'll have to Google plenty while you do, but it'll give you the term and some context around it to kind of at least help you figure out what's going on. So that's kind of where I tend to start recommending as a start. Learn to just run one of these major fuzzers. AFL is kind of the big one. AFL plus, few extra features. There's a ton of AFL family, I tend to call them, like AFL and friends. There's a ton of fuzzers based around AFL. It really is just kind of point and shoot. You have to do a harness usually, but otherwise, largely point and shoot. Some like Live Fuzzer starts letting you take advantage of things like sanitizers, which is a whole new concept that I won't dive into, but it helps you find newer bugs. That's why I also recommend that, so you kind of get exposure on that side of things. And then you've got the entire thing of how do you even run a fuzzing campaign? How do you triage anything that's come out of it? You get a ton of crashes. What do you do with them after that? There's a ton to fuzzing, but at least at the start, like, I don't know, Spectre, I think you kind of disagree with me on starting off by just learning one of the fuzzers.
I don't know if I necessarily disagree. Because it is like a valid route to go with what you were saying, especially with like learning the terminology. It can be useful for that. There's kind of like three major areas, or maybe, yeah, I'll say three major areas for fuzzing, being like using a fuzzer, writing like definitions for a fuzzer, and then the triaging. Um, the triaging aspect is the one that people like the least and like seem to want to skip. There's certain groups, not naming names, that like to just submit crashes to people and are like, "Here, fix this." They don't want to do any of the actual overhead of root causing the bug or anything like that. They're just like, "I found this bug, fix it soon."
I mean, it's
But
hard work.
it is, yeah. Um,
And there isn't also, I guess, while we're talking about the triaging, as far as I'm aware, I've never really seen a resource that talks about like how do you deal. Correction, I've seen one. I haven't done it. It was a paid training course. I think Ring Zero had it as a training, probably at some other conferences too. That was specifically on crash analysis and triaging. So there actually is a resource out there. Just came to mind. I have not done it, so I have no idea on the quality. But on a whole, like I don't like see a lot of blog posts about doing the triaging aspect. And there isn't a lot of research in it. It's only been more recently that I've seen some research on, like, we've talked about the deduplication techniques before on the show, and kind of automated exploitation or figuring out gadgets. I think that was the Kobe paper.
yeah.
There's been some recent research in it, but it is a newer area of research, whereas fuzzing in general and all of that side of things, there's a lot more research going on. So part of me just wants to say that side of things, the triaging, it just comes from experience. You've just got to sit down and actually try, and you'll kind of figure out your own flow. I hate dropping down to just saying like just do it and get good, but
Like the
I
Dark Souls
don't.
2 philosophy.
Yeah, I don't have a good answer on that yet for how do you get practice with it. I could imagine like some sort of training tool that just shows you some crash dumps and lets you kind of play around with it a bit, and figure out like here's how you parse it by having you parse out some things like little quizzes along with it or something. Actually, that's I'll give a shout out to Ada Logics. They have a open source fuzzing course, so it is a paid thing. Um, I think it's .com. Yeah, so they have an open source training one, and they kind of do that. They do spend a little bit of time in their open source fuzzing, or sorry, not open source, applied source code fuzzing. It's a libfuzzer based course, and they spend a little bit of time on that crash analysis too. But a lot of it's really just spent getting you to fuzz and getting you to look at some of the bugs. And it doesn't spend a lot of time on the triaging, but I do recall a section on there. I'm not sure I'd really recommend it for that, but I mean, it's there.
So I guess my main thing with like if you were trying to figure out learning fuzzing is learn the like general usage of fuzzers. So you could do that with like what Z was saying with learning how to use AFL. Maybe even go with like an easier fuzzer potentially, like maybe Peach fuzzer. But after that, figure
Peach, you
out like
still
what
need to kind of
you.
set up your peach pits and everything, whereas AFL, you really can just like point and let it go at it.
Yeah, I guess that's
Like
true.
Peach is more of like a structure aware fuzzer ish. I think it's been a long time since I've used Peach. I still think like because AFL gives you the exposure to all the other topics. That's why I at least like recommending it in particular.
Yeah. But after you get some of that general knowledge of like after, trying to use AFL and play around with it a bit, figure out I guess what you want to specialize in because where fuzzing is such a massive topic and where it's so critical to like development, oftentimes you'll have teams dedicated to fuzzing that are specializing in a certain aspect. So maybe they're developing the fuzzer, writing the fuzzer, or they're writing sanitizers or something like that. Then there's going to be other people who are doing the triaging, the root causing, that kind of thing. So I guess just figure out like which aspect interests you the most and kind of focus on that. Um, I think if you try to focus on everything right away, it's just going to be so daunting, and it's just gonna crush your motivation to continue on with it. Um, so
And
yeah,
motivation is a big thing for sure. And while we're talking about that, like another thing is actually running the whole campaign, is targeting the fuzzer, figuring out where you want to target. How long do you run it before you decide to change to another subsystem? Things like that.
yeah, that's kind of the daunting task, at least for me, when fuzzing is trying to figure out like how long do I run this for and whatnot, and where exactly do I want to target? Because you can kind of like there's no right answer. Depending on your target, there's a lot of different ways you might want to go. You might want to go with a sorry, just one sec. I just got an ad that
Oh,
was playing from the YouTube video.
I
Um,
probably maybe get some audio. Yeah.
yeah, all good. Um, but yeah, you can kind of go with like the broad approach and try to hit everything, and then just find out okay which subsystems are giving me the most reports, and then I'll hyper focus there. Or you can go with the targeted approach off the bat and say like this subsystem looks like it's bad with the bit of manual auditing I've done. I'm going to target that. And yeah, like both answers are right depending on what you're trying to do. And it's context specific, and you kind of learn that intuition as you go. So yeah, what you were saying earlier with the kind of learn by doing, there's not really a great like book or something that you can read that's going to tell you everything about fuzzing because a lot of it is target specific. And it's going to require playing around with it. And there's also a lot of luck and chance involved with fuzzing as well because you're basically like you can have like structure aware data or smart data, but you are ultimately using random data. You kind of have to rely on some some piece of malicious data getting through some various checks or something, or some setup happening to allow a scenario to happen. So there's a lot of luck and time involved with that.
Yeah, you don't happen to have that fuzzing meme around, do you? Um,
Oh, the one
yeah,
with
you
like
know the one I'm thinking of. But
yeah, no, I don't,
also I
unfortunately.
brought up a YouTube video here. It's the Layman's Guide to Zero-Day Engineering. I'll just give that a shout out. The first bit of it does actually talk a little bit of kind of on the fuzzing aspect on how they did the targeting. It's not necessarily where I'd recommend you go if you're first just starting and still learning things. I think spending more time on the process helps, but it is the actual practical kind of workflow that they follow to get up on. Was it Safari? I think they were going after Safari in this. When
Yeah,
they
it
were
was
on
WebKit.
Pwn. Yeah. So like it's a good talk and there's a lot of valuable information there. Not necessarily where I'd start, but it's worth knowing like here's what they actually did to find some legitimate vulnerabilities and to actually target the fuzzer. And they talk a little bit about like the whatever percent they were kind of aiming for on code coverage and stuff, like their metrics, which, it's practical information, part that you'll learn from experience because fuzzing WebKit is different from like fuzzing a random target that, say, your client or your company just uses in house. Your targeting is going to be very different. You're going to have very different experiences depending on how mature the security process is of your actual target. If you're fuzzing R2, you might have bugs just dropping out, in thousands of them. If you're fuzzing something more hardened, probably not so much.
Yeah, I like what they talked about with using coverage as like a metric for roughly where bugs start to shake out. So like with WebKit, I think they were saying like around 60 to 70%. Like when you get into those higher coverage percentages, you're getting into the more well fought over code, or sorry, less fought over code. So there's the bugs that are there aren't being tested as often, or that code isn't being tested as often, maybe not even at all by other people. So you're more likely to get findings there. So yeah, there's a lot of stuff they talk about in that talk that yeah, if you're trying to learn fuzzing, like there's a lot of useful information there, and just in general, like yeah, it's one of the best talks that I've watched. So I did actually find the meme you were talking about, though. I'm pretty sure this is the one you're talking about. Um, yeah, for those listening, it's like the
Yep.
guy in glasses, and it's I wrote a vulnerability scanner that abstracts all the predicates in a binary, traverses the call graph, and generates formulas to run them with an SMT solver. I found one vuln in 3 days with this tool. He wrote a dumbass fuzzer and found 5 vulns in one day. Good thing I'm not a noob like that guy. So, I mean, this is a classic meme. It's always fun to reference, but I can almost never find it without doing like a lot of digging. I was actually lucky that I was able to find it this time.
Yeah, I have it
Um,
saved actually on my NAS just so I could bring it up, but I didn't, or it was being a little bit slow today. But yeah, it's a fair point because there's all this complexity in fuzzing, and then you can just do like this really quick, practically proof of concept level fuzzer that just finds a ton of vulns because there's part of luck in that. You don't always need to make it more complicated than it needs to be. Um, it's an easy trap to fall into, trying to make everything perfect rather than just get something going and working in the first place.
I feel like falling into traps like premature optimization is super easy when you're talking about fuzzing because performance is so it's at the top of everyone's mind when they're talking about fuzzing. You know, more test cases per second means less time to potentially find bugs, and you're less dependent on luck. But because of that, it's easy to like overcomplicate things and try to do really weird things, like whether it be optimization or even just trying to generate really complex test cases. When sometimes, yeah, it's just not really necessary. Um, I did also want to take something in the chat. Somebody mentioned streamer who there's an expert fuzzer who streams on Twitch. So yeah, that's Gamozo Labs. He does some cool streams. I would recommend checking them out if you're interested in fuzzing. He tries to do some weird stuff. Like different times you'll try to fuzz. Like I think he wrote like an Android fuzzer or something using Rust, and he tried to do it in like 2 days or something like that. There's just a bunch of different like topics that he tries to tackle. He is like a huge Rust fan, so pretty much everything he writes is going to be in Rust. So to keep that in mind. Personally, I don't really like reading Rust, so it kind of sucks that like his topics are really interesting, but then when I try to follow what he's doing, it's like it's just pain personally. But if that doesn't bother you, then for sure, like his streams will definitely be worth checking out. Um,
Yeah,
and
streams or
even if you're
videos.
yeah, and even if you're not super interested in the implementation, just like where he's talking through things and kind of working through his thought process. I've checked out a few of his streams before, and they were very useful, and they kind of opened my eyes to some new ideas too. So if you're looking for a source of inspiration, um, his videos could be great for that too. Yeah.
Yeah, and he does some long streams too. I just see here his last one was 14 hours.
Yeah, I've seen him do some insane ones. Because I remember there was one day, I think it was when he was doing the Android stuff. Actually, I forget what. I think he like planted a bug in the kernel, maybe or something. It was trying to exploit it. I forget what the scenario was, but I remember I checked at like 5 or 6 o'clock in the afternoon at my time, and then I somebody linked his channel at like 4 or 5 in the morning, and I'm like, he's still going. It's like,
Yeah, he
damn, I
goes.
never had the stamina to go that long. I don't know where he finds the energy to go for streams that long, man. When I was doing, I think the longest stream I did was like 6 or 7 hours, and I felt like death afterwards. So yeah, but definitely a good shout out to mention him for like fuzzing stuff. He has a lot of cool topics, and yeah, as he just brought up, he has put out a blog before too, which I've read 1 or 2 posts on before. Um, he kind of talks about fuzzing at the meta level sometimes, like What was the Google project? Was it libfuzzer? There was something. There was some Google fuzzing based project that I remember seeing his insights on before, where he was trying to argue against like a direction they wanted to go, and there was some cool insights there. But I can't remember the specifics, unfortunately. But yeah, overall, he's a great resource too for fuzzing stuff. Oh, it was Fuzz Bench. Yep, that's what it was. Z just found the article that was talking about it. Um, so there you go. You can read up on that GitHub issue to kind of see what I was talking about there. That was a little while ago. But yeah, I mean, hopefully that kind of answers the how to learn fuzzing question. It was a bit long winded, but it's kind of a tough question to answer succinctly as well because there's just so many different directions you can go with it, and there's not really a wrong direction. Um,
Yeah, I mean there's all of these options for you to gain depth and just kind of tying in. We've talked before about this idea of being T-shaped, being like having this really deep knowledge in one area and then a wider breadth of knowledge. When it comes to fuzzing, like go deep in some area that interests you, apply that elsewhere to kind of have the more general knowledge. I mean, it's you're not going to go wrong by there's no right answer on where you should dig into it or how deep you should go in any area. And I think we both agree. At least part of it is just doing it. Unfortunately, it's not really a clear path forward.
that pathway of starting off with using a fuzzer like AFL and then specializing, though, I think makes a lot of sense. Um, Now, on that angle a little bit too, I will say, what are your thoughts regarding like on a practical campaign trying to roll your own fuzzer versus using an existing fuzzer and modifying it?
Um, First attempt, don't roll your own. Kind of like not rolling your own crypto. Just don't do it. You're probably overcomplicating things. On your first shot at something, yeah, I would say use an existing fuzzer. Something like AFL general purpose, just see if it works, or maybe not AFL. Consider what your target is. There's a good chance that like something that you're trying to fuzz can be broken down into a pattern that's already known about. And so maybe you shouldn't use AFL. Maybe you do need more like structure aware fuzzing or going for more grammar aware, something like that. Fine. Then look for a fuzzer that's already doing that rather than trying to reinvent the wheel. Once you've done that, if you're not happy with the results or something, fair. I mean, there's legitimate reason to go and implement your own fuzzer. It's a lot of effort, so if you're say a consultant or something, you're probably not going to be going through that effort. It's just not worth the time investment. But if you run into the same sort of thing all the time, it can make sense. Or if you're working on a long hard target, it can make sense to try and do something like if you're running on a target that's been fuzzed by like everybody, it kind of makes sense to at least try and be doing something different that other people aren't. But you need some sort of inspiration you're on your own that's different from what everything else is doing. Like I wouldn't recreate the wheel.
Yeah, and that's exactly why I brought it up. Is like unlike crypto, where rolling your own never really makes sense because it's already been done and it has like an established like developer like the major libraries will have a developer team around it and will be able to support it far better than you will be able to support your own weird solution. With fuzzing, it does make sense, at least in some cases, to roll your own because, like you said, if you just fuzz with the same thing that everyone else is fuzzing with, you're going to find the same issues probably. You might get lucky and find something that's useful that doesn't collide, but that's not really a safe bet if it's like a well fuzzed and research target, which where you're going to be using fuzzing in modern applications, like it's leveraged hard in fuzzers. That is where a lot of the cutting edge research takes place. And
Yes,
yeah,
fuzzing
if you
is
just pull
leveraged
a
hard in fuzzers.
oh, sorry, did I say that? Uh,
That's at
That
least
was
what I
that was
heard.
really dumb. Okay, sorry. Fuzzing is leveraged and taken advantage of a lot in the browser space, is what I meant to say. Um, and so, yeah, if you just pull down like Domato or some browser fuzzer and just run it out of the box, you're probably not going to find anything interesting or unique. But rolling your own, you could end up finding some of the more unique issues that other fuzzers can't catch. That said, you could also modify an existing fuzzer, which will be a lot easier, and add definitions or harnesses or something like that to it. And that's a viable route to go too. Now, obviously, there are some trade-offs there. You will have to become accustomed with the fuzzing code base and get familiar with how to integrate your code into there. But you also don't need to lay all the groundwork needed to do the fuzzing, which, depending on the target, could be a lot of work. So
Yeah, that's where I'll shout out Live Fuzzer. That is one of the things I like about it, is the fact that it's really easy to integrate into its framework. It's actually uh, one of the bases for Google's Cluster Fuzz. And if you're just wanting to get some practice writing some fuzzers, learning Live Fuzzer, you can write fuzzers that go against different aspects of Chrome, and Chrome actually pays out a bounty, so you'll get the normal bounty for any bug your fuzzer finds that others don't. And you'll get a bonus on top of it, so a little bit of monetary money just for writing a fuzzer, basically. And not even needing to do all the triage on the bug reports.
yeah, I
But that
forgot
is
about
one
that.
reason I
Good show.
like Live Fuzzer, is it's pretty easy to start doing your own thing and kind of integrating into it. That is also one of the features that AFL++ adds on to AFL. AFL is a little bit of a pain to like do your own mutation or something on. You've basically got to fork it. AFL++, it is at least a little bit built in.
Yeah. So I guess with fuzzing, you just, once you have the basic knowledge of like terminology and how to use a fuzzer like AFL, figure out like the target specific requirements of how you're going to fuzz it, what's involved in writing a harness, and then yeah, you can do like the specialization with whatever you want to focus on. But yeah, that's pretty much all I have on that discussion. Unless you have anything else, see, we'll move to shoutouts.
Um, One thing I'll add yet, since we've used the term harness a couple times, basically most of the fuzzers will send you their input in some particular way, such as first argument is a file name. You read the file, you then process that and send it to your actual target however you want. So the harness is that code that it sends it to, because most programs aren't going to be able to take that input as just like first argument, and that's fine. You usually want to do some more. So that's what a harness is. We've been using that term a little bit and probably should have explained it.
Yeah, it's basically the glue between the data generation and the target. That's the way I like to think of it. But yeah, that's fair to bring up because, like, yeah, one of our criticisms was the fact that terminologies aren't really too well explained. So yeah,
Yeah, I
that's
mean,
good that you explained it.
it's hard. I'm sure there's terminology we've used here that just wasn't right. Thank you, Valentine, or is Valentine, again for gifting another sub. Well, first time this episode, but thank you.
Yeah. So we'll move into our shout out here. This is kind of a last minute ad because I just saw it posted today, but oh, I just lost the link because I went to get the meme. But the temp out, which is like a newer Zine, the second issue came out today. Um, Mostly focuses on elf stuff. There's a lot of some elf parser bugs, um, preloading the linker for fun and profit, elf binary mangling. The one that I read a little bit of was bashing elves like a caveman, which talks about basically hijacking the metadata related sections in elves. So like the PT notes segment, for example, and infecting elves using those sections for inserting some payload or whatever. Um, Nothing like super groundbreaking there, but there's some articles here that are interesting. I always like sharing stuff that's related to elves because it's just kind of an interesting file format. It's one that people gloss over a lot, but um, they can be complex, and there is some cool tricks you can take advantage of there, and that is like kind of the focus of a lot of the topics in this volume. But yeah, I mean, whenever there's a new Zine that has some interesting reads in it, then we like to shout it out. So yeah, just wanted to shout out that this temp out volume 2 is out, and yeah, might be worth
Yeah, and
checking
I
out for you.
think we called out the first one also quite a while back.
I think we did, yeah.
Yeah, and I mean, it's more focused on like the old VX stuff. But I mean, kind of low level information, so overlap at least with the Vuln research.
Yeah. Uh with that said, that's everything that we have for this week, I believe. Unless you have anything else to add, Z, we'll go ahead and wrap
Nope.
it up. All right, cool. So thank you to everyone who tuned in. The VOD will be up on Twitch immediately or on YouTube or other platforms tomorrow. Feel free to follow our Twitter and join our Discord for notifications for when we go live. Or if you want to chat with people in the community, you can do that in our Discord as well. But yeah, we'll be back next Monday for the bounty episode and Tuesday for the binary episode. Until then, take care.